So far we've explored how good classic trigonometry, which is right angle trigonometry, is for finding missing sides. But what about finding missing angles when the sides are known? We can go back to this old example and refresh our memory a little bit, since it's been a while since we saw so, if you've been going in order. But if we use the 38-degree corner, in which A is opposite and 15 across from the right angle is hypotenuse, we set up sine 38 is opposite A over hypotenuse 15, and when we cross multiply, we ended up with 9.235 rounded off for this side. But what if we knew that this side was 9.235 and we knew that this side was 15? Of course, we could find this side with a squared plus b squared equals c squared. But what about finding this angle if it wasn't here? What if we knew this side and we knew this side, but we didn't know this angle at all? How could we get it back? So look over here at this example in which I put the 15 on the hypotenuse and the 9.235 over here, but I left angle A blank. How could we figure it out using our calculator? Well, we know if we're interested in angle A, that 9.235 is opposite, and 15, as always, is the hypotenuse. So once we have the O and the H, we know we want to use so, but its sine of what angle is 9.235 over 15? We know the sine answer. It's the question, the angle, that we don't know. That's what inverse functions do. And if you look above the sine key on your calculator, you'll see where the inverse function is. It's the little sine minus 1 that appears above the sine key. In order to get to it, you have to press the second key in the upper left-hand corner, then press the sine key, and this is what will appear. So when we tell the calculator that we're looking for sine inverse of 9.235 divided by 15, and for some reason I did 9.235 divided by 15 on my calculator first and stuck that in there, but I wouldn't do that in real life. I would just type in 9.235 divided by 15, and that's the angle that the calculator gave me, which is 37.9955, which is in essence the same 38 degrees we started with. So if you know two sides of the triangle and you're looking for the angle, you can figure out how those sides relate to the angle you're looking for. If we were looking for angle C, then 9.25 would have been adjacent to C. 15, of course, is always the hypotenuse. We would have written cosine A equals 9.235 divided by 15. We would have put into our calculator second cosine, and we would have typed in 9.235 divided by 15, and the calculator would have given us the angle for angle C, which we can figure out or guess is 52 degrees, because 38 and 52 add up to 90, plus 90 is 180. But why don't you try it yourself? Type into your calculator second cosine, and then 9.235 divided by 15, and see if you get 52 degrees. You can find any missing angle as long as you use the correct ratio name and use second with the correct ratio name. I hope that helps.